Okay, Broncos, welcome back. So now let's finish section 9.2. Yeah, 9.2. Let's finish it with this video here. So let's go to the whiteboard and let's begin. So example, find the length of the given line segment. All right, so example, find the length of the given line segment. So let me give you a diagram with a line segment, and it's your job to tell me the length of that line segment. So let me wipe all this out the way. Let's get this out there. So let's go to the axes. And let's say we have a line segment like this. Suppose the coordinates are, let's go with 6, 5. And the endpoint, let's just make this up. Let's say this is like at, how about 10, 12. There we go. And I want you to be able to tell me the length, right? The measure of the length of this line segment. So there's two classical ways of doing this. The first option is you can go to your distance formula from high school. You can even like look up the formula if you want to. That's an option. Distance formula. Or you can do what we've been doing, trigonometry, right angles, Pythagorean theorem, like so. I could grab, let me switch colors. I could go to green and I could go for a walk from here to there and then stop and go straight up. So that's 90 degrees. And then we can find the measures, right, the lengths of this right triangle. See, we just made a right triangle. And now if you count from 6 to 10, that'd be 4. And if you count from the y coordinate to the other y coordinate, that would be 7. So we have a right triangle where the sides are 4 and 7, the legs. You just subtract the x's and you just subtract the y's. And now we can go Pythagorean theorem to find the length of the segment, which now plays the role of the hypotenuse. And Pythagorean theorem would tell you that it's the square root of, well, what's 16 plus 49? What is that? 50, 60, 65. It looks like the answer is going to be the square root of 65. Pythagorean theorem, which you've done a million times in this class. So we had a line segment with 2 points. We did a right triangle. Pythagorean theorem gave us the square root of 65. Now notice that if I had gone red, if I had done red instead of green, same answer. It doesn't matter how you construct the right triangle from this line segment, whether you go up or down, you get the same figure, just with a different orientation. All right, so let's use this idea. Let's keep this in mind for our next examples. Maybe not the next one, but the one after. So how about we go here? How about we have example, solve for x. Let me give you now a triangle, and you have to tell me the value of x, the approximate value. If you'd like, that would be fine. So let me get this out of the way. All right, so let's get this out of the way. Here is your triangle. Boom, boom, boom. And we have a side that says square root 7. Let's say this is 84 degrees. Let's call this 39 degrees. And your goal x is right there. How about actually we put it down your watch? We want x to be there instead, yeah, not the angle. So for here, I recommend that we use, as we saw last time in class, the law of sines, right? So for the law of sines, you want to have an angle and its corresponding side. The only side that I know of is 7. So I have to know the angle across from it, the angle that produces that square root 7. But it's not given to me. It's all good because I know that a triangle contains 180 degrees. And I know that I have the other two. So on a calculator, we should go 180 minus 84 minus 39. And that'll tell us the missing angle. So on my calculadora, I can type that in. And the missing angle is going to be 57 degrees. 57 degrees. So you want to fill that in your notes. 57 degrees here in green. And now that we have that, now we can begin the law of sines. So our setup from last week would say the sine of 57 is to square root 7 as the sine of, you want to use 39. You want to use 39 because across 39 is the goal, x. Notice in my setup, in my equation, I didn't use the 84, but that's okay. You don't have to use every number every single time. We can solve this equation here to find x. So if you cross multiply, we would have the square root of 7 times the sine of 39 equals x times the sine of 57. And the goal is to find the value of x. So to get x alone, we can divide both sides by sine 57, because that's a number, right? And these are gone. Now, while you're copying, I can type this in for us. So we have square root 7 times the sine of 39 degrees. Yeah, my calculator is set to degrees. Make sure yours is as well. And final answer, we get about 1.99, about 1.99. So x is about 1.99. And I would take a moment to make sure that I even believe this answer. Let's compare. Compare 1.99 with the square root of 7. Square root of 7 is bigger than 199. And that makes sense because square root 7 came from 57 and 1.99 came from 39. Which angle is bigger and which side is bigger? See, the bigger of the two angles, these guys, has the bigger of the two sides. So a bigger angle should go with the bigger side if we're talking about a triangle. All right, done with this question. Last example here on this video. Last example. The goal is, so let's jot down the goal. Example, solve. Let's go with x again. Solve for x. Now, this time we're going to go back to the axes. Let's go back to the xy axis. And here is your model. Let's go like that. Let's go like this, and like that. Let's try that again. Like that. Put a point there and put a point there. And let's say these coordinates are 5, 7. And for this one, we're at 10, 6. And the goal is to solve for x. And you're given that this is 23 degrees. All right, right triangle in the first quadrant, we have all the vertices. This one is at 0, 0. That's at the origin, okay? The origin. We have 23 degrees for one angle, and we're trying to find x right there. Let's solve for x, and that'll conclude section 9.2. And then we can start 9.3 the next time we meet in class. All right, so what do we do here to solve? How about we find the sides of this triangle? How about we look here? How about we focus on this red? We can find that red by going to the middle and making this blue triangle, right? We can go like this. We can find the red by looking at the blue. Now, you know the blue, this is going to be 10 and this is going to be 6. I know that because of this point, right? This is x and this is y. This is sideways and this is up and down. That's how I know that this blue triangle is 10 sideways and then 6 up because of the directions or the coordinates of that point. And now that we know these blues, we can find the red through Pythagorean theorem, right? Like we did in the first example of this video. We can go Pythagorean theorem because we have this right triangle. So do Pythagorean theorem for the 100th time, and you'll find that the red bit, the red one, the hypotenuse, would be the square root of 136. So that takes care of the red, right? 136, square rooted, just whatever that is. So we know that this is going to be the square root of 136. And how about, if it was up to you, would you now find the red or would you find the purple, right? Take a moment and ask yourself, using the technique that we just did to find these sides, would you find the red or would you find the purple? And then justify why you would find the one that you would find. If me personally, the one I would find next, I would find color purple. And here is why. Because across from purple, I know the angle. Across from the red, I don't know that angle. So my strategy is going to be find the purple side, like Pythagorean theorem, and then go law of sines. So let's make sure this works out. So let's focus now on this purple. So to find the purple, what we can do is make this right triangle, right? We can make that right triangle. So how much would be this part here? Well, compare the y coordinates of those 2 points. 7 and 6. The y coordinates are 7 and 6. That is a separation of one space. What about the sideways, right? Compare the x's. One of the x's is 5, the other is 10. That is a separation of 5. So I know that on this right triangle, that if I draw it like this here, that I know that this is going to be 5. I know that that's going to be 1. And Pythagorean theorem would quickly tell us that the hypotenuse is the square root of 26, where the hypotenuse would be this guy here, right? The one that we were trying to find right now. So that is going to be the square root of 26. So let me erase some of these things, and let me just put down the square root of 26. And I would propose that now we can find x with law of sines. And that setup would go like this. It would say sine of 23, right? Sine of 23 is the square root 26, as the sine of angle x is to its opposite side, the square root of 36. Let's cross multiply this here. So cross multiply, that'll tell you square root 26 times the sine of x equals the square root of 136 times the sine of 23. We're trying to get x alone, so let's divide both sides by square root. 26, both sides, square root. 26, these cancel. And now to get x alone, you're going to have to make sin, sine, go away. So to get rid of sine, you should use sine inverse, referred to as arc sine. So our x here, our final answer, x should equal the sine inverse of, well, what you'd have to do is take this green number, plug it in there. So while you're copying, I'll finish this up for us, so we can have our notes here completed. So sine inverse of square root 136 times the sine of 23. And underneath we have square root of 26. Okay, we're in degrees. So sine inverse says 63.3 degrees. So x is about 63.3 degrees. Let me just box this in before you guys leave. And let's actually make sure we believe this. X is about 63.3, so that x is about 63.3. Do I believe that? Yes, I do, because 63.3 is bigger than 23. And its side, this, is bigger than the other side, that. So I believe this just logically by comparing. I totally believe this. So this example should wrap up 9.2, law of sines. And then when we meet in class, we do 9.3, which is on the law of cosines. See you guys soon. Bye.